This video will introduce you to independent t-tests, which are very different than the dependent t-tests, but the idea that we're going for a change or a comparison of means is the same. So we're still comparing the means. In a dependent t-test, we were comparing the means of one group of people or a related group of people. In independent t-tests, we're comparing the means between an experimental group versus a control group. So perhaps it's a treatment and a placebo. Or we're contrasting subgroups, maybe boys and girls in a class, or smokers and non-smokers. The point is that the two groups are unrelated, but they're from the same population. So we're comparing the means, but they came from the same population. We want to know if there's a difference in the means. So the first thing we do, of course, is set our hypotheses, and then our criterion level. And then before we calculate the test statistic, we have to do something else to make sure that, well, to find out whether or not there's what we call homogeneity of variance. So let me stop here and talk about that really quickly. First thing you have to look at, because the homogeneity of variance is going to let us know whether these two samples we've polled really are from the same population. Are the groups roughly the same size? They do not have to be equal size. But if one group has 2 in it and the other has 20, that's not going to work. But roughly the same size, you're just fine. So let's talk about variance. Variance, you'll remember, is the square of the standard deviation. So it's showing the spread in scores and the variation in the population, the variance. The null hypothesis is that the variance from one group is going to be the same as the variance from another group. They're going to be homogeneous. We're making an assumption of homogeneity, of variance. Now, if we randomly pulled these two groups from a population, we really think that our null hypothesis is going to work. Their standard deviations should be the same and their variance should be the same. SPSS runs a test for us, and it's called Levine's test for equality of variances. Keep in mind that the null hypothesis is that the variance is going to be the same for both. We're going to assume that there are equal variances. The SPSS results look like this, and there's the Levine's test for equality of variances. It gives it to us as an F statistic and a significance value. And notice that the significance value in this case is 0.71. You'll remember that if our P is greater than our criterion, we keep the null hypothesis. So in this example, we could say that the assumption for homogeneity of variance was met. F with 15 degrees of freedom equals 0.14 and P equals 0.711. There's our degrees of freedom. How we use Levine's test is that when we are looking for the t statistic for the change in the mean or the difference in the means, we use this line if we can assume the variances are equal, and we use this line if we're going to assume they're not equal or they're not assumed to be equal. So that's the part we have to insert in our steps to in hypothesis testing. So next we calculate the test statistic. And you have to stop and be careful about degrees of freedom. In our paired samples or dependent group, Billy has 2 scores, and each of his colleagues has 2 scores. It's one group, but 2 scores. So our n is 6, and our degrees of freedom are n minus 1. In independent samples, it's different. We have Sam, who has a score, because he was in the treatment group, and we have Felicity, who has a score, because she was in the control group. So we have 6 here, n equals 6, and our degrees of freedom are n minus 1. And we have 6 in this group, n equals 6, degrees of freedom equals n minus 1. So in our independent group, when we are doing calculations, our n becomes 12, and our degrees of freedom are n minus 2. So let's stop and think about all of this then. When we're doing paired samples, our dependent variable has 2 scores. We've got an independent variable that's the intervention or that we did. And examples of that are pre and post test, a before and after, maybe grades from quarter 1 to quarter 3. When we're working with independent groups, we still have our dependent variable, of course, because that's what's of interest to us. And we have 1 score from each group. We still have our independent variable, which is our intervention condition. And examples of that are an intervention, no intervention, medicine, placebo, treatment, control. All of those things would signal independent. So when we're setting up our data, we have to do something a little different. When we've got paired samples, we've got a student, we've got variable 1 that is their score at time 1, and variable 2, their score at time 2. It's pretty straightforward. But when we're working with independent samples, we actually have a treatment group and a control group. It's the same variable, it just has 2 conditions. And then we have variable 2, which is going to be our dependent variable in this case, which is their scores. Think of it this way. Variable 1 is a condition, and variable 2 is the score that's related to that condition. So we have this group, the treatment scores. Sorry about that. Dogs aren't good at when you're recording videos. So we've got 2 groups that we're comparing, and we're comparing them on their score. So we call variable 1 a grouping variable. So when we're looking at SPSS, it will calculate our T for us just like it did with dependent variables. Or dependent groups, sorry about that. And it'll calculate it out, and we report it as with the degrees of freedom, and our P equals 0.013. So then we use that to make a decision about the null hypothesis.